Hello everyone, this is the review video of Chapter 8, Quadratic Expressions and Equations. In this video, we will review math vocabs and concepts on quadratic expressions and equations by factoring and solving equations using zero product property. The first lesson was on adding and subtracting polynomials. To begin with, the polynomial is a monomial or sum of monomials. When you have two monomials, we called it binomials. If you had three, it was trinomials. If you have more than three monomials, they didn't have any specific names, so we just call it polynomials. When you are asked to write a standard form, you're going to find the degree of each terms and then write from greatest to least degree. So for example, if you have x to the fourth power plus 3x squared y plus 4, this is written in standard form because your highest degree is 4. And this one has degree of 3 by adding 2 plus 1 right here. And then the next one is degree of 1. And remember, the constant has degree of 0. When you're adding or subtracting polynomials, make sure that you're grouping the like terms. Here's an example. Find 2a minus 5 minus 3a plus 1. As you see, they are in two groups, where if I subtract 3a plus 1 from 2a minus 5, let me write 2a minus 5 as it is. However, when you're subtracting, keep in mind you can see this as you're distributing if you constantly forget how to subtract 3a and positive 1. So if you want to, you can write just one more step saying negative 3a, and if I distribute, you will get negative 1. Now you're going to combine the like terms. 2a and negative 3a, they both have common variable. So 2 minus 3 will be negative 1, where I can just write negative a. And when you're looking at this negative 5 with negative 1, when you combine them, I'll get negative 6. And that's how I know this is going to be a simplified form. In lesson 2, you are learning multiplying a polynomial by monomials. Keep in mind, you are going to use the distributive property, and the products can be simplified by combining like terms. So lesson 2 was much different than what you've learned already in past chapters. However, the only difference, if I may say, it just has longer terms because now you're dealing with polynomials. Lesson 3 was multiplying polynomials, so you were using distributive property as what you just talked about in lesson 2, but also this was a time that we were learning about FOIL method. I did mention that I'm not a huge fan of FOIL, the word, because it only works with binomials. If you have more than two monomials, then you are going to use just distributive property, which to me, I guess I'm fine by just using distributive property for all of them. Here's an example of lesson 3. This is multiple of two binomials. So what I'm going to do is multiply 2n with n and 4. You're distributing this, so you will get 2n squared, and then you'll get plus 8n. Now you're going to do one more time, but this time with negative 3. So negative 3 times n, which you will get negative 3n. And then the next one, negative 3 times 4 will be negative 12. Now when you combine them, since 2n squared doesn't have any like terms, I'm just going to write down 2n squared. 8n minus 3n could be combined by writing 5n, and then the last term will be negative 12. This is going to be a expanded form after you distribute. In lesson 4, this was a lesson that's starting on how to distribute quicker way. For example, there were three types of special products. The first one was a square of a sum, which means when you had a plus b squared, you will have a squared plus 2 times a times b plus b squared. When you had square of a difference, this was when you had a minus b squared. Only difference is now that you're going to have negative instead of positive, a squared minus 2ab plus b squared. Product of sum and a difference, this was a last special product. When you had a squared minus b squared, that is equal to a minus b times a plus b. I already covered how I could prove that this will be the form that you can use in any cases of square of a sum. If you haven't done it yet, I'll leave a link underneath of this post and please review as needed. So for example, if you have 3y minus 2 squared, this is a form of following a minus b squared. So let's say a is your 3y, and the minus stays the same, so b has to be just positive 1. This was following the form a squared. Then you're going to multiply everything that you see. So 2 times a times negative b will become negative 2ab. And then I will have negative b squared, which will give you positive b squared. So all you're going to do is you just replace the numbers with it. So 3y, if you had 3y squared, minus 2 times a was 3y, and then b is 1, plus your b squared, b was 1, so 1 squared will be equal to 3y squared will be 3 times 3 is 9, y times y is y squared, minus you will get negative 6y, and then plus 1. This was the quicker way to solve how to expand 3y minus 1 squared. If you were not sure how to write a special product, then you can do alternative by expanding this. So something squared means you have that group twice. And when I distribute, as what you already learned from the previous chapter, 3y times 3y will be 9y squared. 3y times negative 1 is negative 3y. When you multiply this one more time, you will get negative 3y again. Negative 1 times negative 1 is positive 1. So now if you combine the like terms, 9y squared minus 6y plus 1 will be exact same answer as you see. In lesson 5, this is the part where we were learning about how to factor by using distributive property. The first step in order to do so was to find greatest common factor, another word of GCF. Also, you were using zero product property, where if you have an equation that's equal to 0, and if it's already in factor form, you could say if AB is equal to 0, then either A is equal to 0 or B is equal to 0. So this will give you mostly two answers except certain cases where you have to set this part has to equal to 0 in order to make your equation equal to 0. Or you could say B is equal to 0, is what they were explaining. Here's an example. So if you already have an equation and that is equal to 0, double check is it in multiplication format. And it looks like they took out the greatest common factor b from both terms. So what they're saying is, if I solve this, the first term right here, this b has to equal to 0, because if this was 0, whatever this term becomes, it doesn't matter, as when you multiply by 0, it will automatically become 0. Also, you will do another one saying, what if this part right here, this group, was equal to 0? And for the same reason, when you multiply whatever this b is right here times 0, you will get the 0. So as you see, the b is equal to 0 automatically. However, for this one, if I solve it, b plus 17 is equal to 0 if b was equal to negative 17. So I can say my answer is b is equal to 0 or negative 17. And this is going to be my answer when you solve this equation. Both lesson 6 and 7 were using trinomial with quadratic equations. In order to factor this, remember that I share with how I learned in Korea or how I would teach now. My kids used to call it Miss Kim's method. However, it's not really mine, so I decided to just call it K's method. So Kim and Korea. That makes sense to me. What should be the term M and P? So that way when you are adding them, it will make your value B. When you multiply them, it should equal to your C value. This used to be my favorite as I practiced a lot of these ones. It will be a lot easier if I show you an example right away. So here's an example of trinomial with quadratic expression. So I'm trying to think, what two numbers do you need to multiply to get the m squared? In this case, if I had m and m times m is m squared. Now think about two numbers. When you multiply, you get 42. I could come up with the combinations. So let's say you're going to get 42 by multiplying. If you had a 1 with 42, 2 with 21, 3 with 14, 4 doesn't work, 5, 6 works with 7. So far, I think these are all the positive answers that I could come up with right now. And now you're going to think about when I add them, I have to get 13. 1 plus 42 is 43. 2 plus 21, 23. 3 plus 14, 17. 6 plus 7 is 13. And as you see, my answer that I was looking for is I need to get 13, which is this case right here. So if you had 6 and 7, when I cross multiply this, m times 7 will be 7m and m times 6 will be 6m, and when I add them, I do get 13m, and that's good. So here, when you rewrite this, keep in mind, I always emphasize this, you need to write a cross. So I know that you cross multiply, and this is why it could be confusing, but when you write this one, you're going to go m plus 6, since this was positive, times m plus 7. Because if you distribute, this will be expanded to m squared plus 13m plus 42. And that's how I know this is going to be my answer. Lesson 8 was the case of using difference of squares. So if you remember, the difference of squares were using a squared minus b squared. Main concept of this lesson was solving equations by factoring and using ZPP. I have a binomial, but in between them there is a subtraction. Terms of square. For example, in this case, 4 is square of 2 and m squared is square of m. So I could write this as 2m squared minus 25 is square of 5. So I could write like this. Now that you see this could be your a, where 5 could be your b, keep in mind it's not negative 5 because negative came from the formula. So then I could rewrite this as you will have 2m minus 5 for one term, and then you could write 2m plus 5. So that way when I distribute this, you will get 4m squared minus 25. And that's how I know this will be my vector form. The last lesson was on perfect squares. So this was going back to your a plus b squared or a minus b squared forms. Now this was the case when they were not equal to 0, instead you had another number next to it. So when you have already perfect square that's equal to, let's say 5, 6, 7 or whatsoever, the first thing was you're going to undo your square by using the inverse operation, square root. Then when squares are gone, you can solve for the variable, whether normally it's x or y, but it depends. If it was not perfect square form, you could have still used zero product property. Now just to let you know, when you are doing square root, keep in mind square root will cause two different answers using plus or minus. The example that I had was if I have x squared is equal to, let's say, 25. I'm asking you, what two numbers do you need to multiply to get 25? The most common answer that my students tell me right away is 5. However, there was one more, and would you be able to say what that was? If I had negative 5 times negative 5 will be still positive 25. So that's how we talked about when you take up the square root, you will always write plus or minus. Of course, there were cases when we were looking at it, the negative cannot happen in certain real-life situations. Here are some examples of perfect squares. So for example, as you see, this is already in perfect square form where that is not equal to 0. If it was equal to 0, you could have used ZPP right away. But since it's not, what you're going to do, you want to get rid of the square first. Using inverse operation, if I take off square by taking square root on both sides, this will become 4x plus 3 is equal to, remember, it's going to be plus or minus square root of 25, which is 5. So then I'm going to solve this by 1 subtracting 3 on both sides. So then it becomes 4x is equal to plus or minus 5 minus 3. Before you continue, let me split this. So 1, when 4x is equal to, if you had a positive 5 minus 3, it will become 2. The second way was when you had 4x is equal to negative 5 minus 3. If you're using negative 5, then it becomes negative 8. So now that you will see two different answers. 1, when x is equal to, if you divide by 2 on both sides, 1/2. Or when x is equal to, if you divide by 4 on both sides, this becomes negative 2. And that's how I know this will be my answer of the equation. Here's another example. Again, as you see, this is already in perfect square form where it's not equal to 0. So ZPP is not what you're supposed to do because ZPP requires to have equal to 0 to begin with. The first step now, again, will be taking out the square by using square root. If I do so, the square and square root will be gone. And then m minus 2 is equal to plus or minus. Since square root of 5 is going to be irrational number, let me just keep square root of 5. Since I'm solving for m, if I add 2 on both sides, m is equal to plus or minus square root of 5 plus 2. Which means you could use a calculator to find what square root of 5 is about, or you can just leave it, m is equal to positive square root of 5 plus 2, or you can write negative square root of 5 plus 2. If you are using calculator, the square root of 5 is about 2.23. So this one will be 2.23 plus 2, which will get you 4.23. On this case, if you had negative 2.23 plus 2, this will be about negative 0.23. So that's up to you how you want to write it. In my classroom, I'll be fine. Either you write it as plus or minus square root of 5 plus 2, or you separate them like this. And if they are allowed to use calculator, I'll also accept the numbers in decimals. To give you a nice slide of review on factoring, when you have two terms, you're going to use a square minus b square because there was no form using a square plus b square. So this is the only format, and you're using a plus b times a minus b. So when you had trinomial, such as ax squared plus bx plus c, or when you had ax squared minus bx plus c, where a, b, and c could be any integers, then you're going to use what I call case method. So think about two numbers when you multiply, you have to get ax squared, and then think about another two numbers when you multiply, and you will get c. When you cross multiply them, you have to get the b value. When you have four terms, such as 3x to the fourth power minus 6x cubed minus 3x squared minus 6x, there were a few different ways, but first we were separating them into the groups and then factor individually. This is the end of the review. Thanks for learning with me. If you have any questions, please leave a comment.